In this video, I'm going to be talking to you guys about central angles and inscribed angles and the relationship between the two. All right, so in the circle below has a center at M. Suppose that KL, and once again, I like to draw on my circles here. So KL, whoops, KL, we got that arc angle to be 106. All right, and then it wants us to find the following. So it wants us to find just the angle of KJL. So KJL, so that would be this angle here. And then it also wants us to find the angle KML. And remember, I said this video is going to be talking about inscribed angles and central angles. So which one here is going to be our inscribed angle? Yep, it's going to be this KJL. Remember that an inscribed angle is an angle with its vertex on the circle and the sides contained as chords. So these sides of the angle KJL are the chords. So this is the inscribed. Yep, and then that would mean this is the central angle. Central. Excuse my handwriting. I'm going to open up Desmos here real quick, and I just want you to look when I move these sliders around. Okay, so we have our central angle right here and our inscribed angle right here. And as I move, my inscribed angle around on the circle, on the circumference, nothing's changing, right? The angle's not changing. The chords where they intersect the circle aren't changing, so my angle isn't changing. And then look at the numbers of the central angle, in relationship to this inscribed angle. And watch as I move now where these chords are intersecting this circumference. Okay, what's happening to my angle? Let me see if I can get it. So originally we started at, I think, we were at like 100. Yeah, 100 and then 50. So as I move this, let's see if I can get it right on a whole number. 60, 60, and 30. So do you notice the pattern? 120 and 60-ish, right? The central angle is always going to be twice as long as the inscribed angle, or the inscribed angle is always going to be half of the central angle. Okay? But we don't know the central or the inscribed angle, and we got to figure that out. Well, to figure that out, here's what I'm going to do. I'm going to take this circle that I drew over here, and I'm going to split that up into 4 equal sections. I'm going to make some perpendicular lines in there. And when I make those lines, well, we know that since I split them up into equal sections, we know that these have to be right angles. So we know that this central angle right here is going to be 90 degrees. Well, if we split the circle up into 4 different sections, then what is one of these arc lengths going to be? Okay. Well, a total circle has 360 degrees. If I split it up into 4 sections, each section, right, each arc degree is going to be also 360 divided by 4 is equal to 90. So the central angle is always going to be equal to the arc angle that its rays shooting out from the angle intersect the circle. So over here, if LK is 106, right, the arc angle is 106, my central angle, or KML, is also going to be 106. Well, and then we said, well, my inscribed angle is just half of my central angle, right? So to find my inscribed angle, I can take 106. Whoops. I'll go over here. 106 divided by 2. And I should get 53 degrees for my inscribed angle. And 106 degrees for my central angle. All right. Let's practice this one. So it's saying the circle below has a center D. Suppose that the arc angle BC is 116. Once again, I'd like to kind of highlight so I know where I'm kind of working here. Whoops. 116. Find the following. So it wants BAC and it wants BDC. Once again, it wants the central angle and it wants the inscribed angle. And what's really important is that they both have the same point where its rays are intersecting that, or where these chords here are intersecting that circumference of that circle. That's why this rule works here. So the angle BDC, okay, angle BDC, or our central angle, angle BDC is going to be equal to 116 degrees. And angle BAC, or our inscribed angle, is going to be 116 divided by 2. We take 116 divided by 2, we should get 58 degrees, I believe. And there you go.